So a student sent an email asking me about your third problem on my math lab, which was 8.2.17, and you were asked to find the limit of the sequence or determine that the limit doesn't exist. So find the limit or determine if it doesn't exist. So the problem at hand, or the sequence that we're looking at, is tangent inverse of n over 20n. So you needed to find the limit as n goes to infinity of tangent inverse of n over 20n. And the key to unlocking this limit is recognizing or recalling the graph of tangent inverse. So tangent inverse of x looks like this, and there are asymptotes here, right, at negative pi over 2 and pi over 2. But we're actually going to be exploring just this piece of it because we're looking at n, right, positive n, so n is going to infinity. So let's examine the limit now. Knowing this graph, tangent inverse of n, as n gets larger and larger and larger, this is going to get closer and closer to that asymptote. So the numerator goes to pi over 2. The denominator, as you get bigger and bigger, continues to grow. So pi over 2, a constant over a really large number, the limit is going to be 0. So that is the answer to this problem. The limit is 0. But I wanted to go a little bit further with this one. The answer choices were the sequence is monotonic but is unbounded, the sequence is monotonic and bounded, the limit is blah, and continues. So what I would like to say here is that your choices involved vocabulary describing the sequence as monotonic or not monotonic, and bounded or not bounded or unbounded. And in this case it's both monotonic and bounded. Well, how do I know that? One way of looking at this, and I said there's 3 ways, you can expand the sequence, and I will put a few numbers out there for you. If you go to your calculator and put it in radian mode and get some values for this sequence, you'll see that the first term in the sequence is 0.0392, and I'm only going out 4 decimal points. The second one is 0.276, and the third one is 0.0208, and you're going to continue. So this is monotonic non-increasing. The other way to check is through calculus, but in this case the calculus gets a little bit nasty because you have to do the quotient rule and all. So what I would say is to list out is probably your best bet, and it is bounded, right? So this is n equals 1 because you can't start with n equals 0 because the denominator would be undefined. So for n equals 1, this thing is bounded, and the upper bound would be 0.0392, and your lower bound is 0. So this is non-increasing. It is monotonic. It's a decreasing sequence. The other thing you might be interested in is when you graph this thing. It's a little exaggerated. Let me redraw that for you. When you graph it, I went out to Maple and graphed this. And it looks something like this. Okay? And again, we're looking at this piece of it. So you can tell that this is a decreasing function. And what do you know about decreasing functions? The first derivative is going to be less than 0. So, you can attack this problem from different angles. I hope this video helps.